In this video, we're going to be looking at our laws of logs. Now, there's three laws really which are very important to us, and then a couple of extra things which are good results. The first one is, and this is very important, they all have the same base. So this is log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. And you need to be able to work both ways. So you need to be able to go from here. We've got the sum of two things, so sum of two logs. Goes to log to the base a of bc, and also if you have log to the base a of bc, you have to be able to know that that is going to be the same as log to the base a of b plus log to the base a of c. So where this can be used, and here we haven't mentioned any base, that means the base is 10. So log to the base 10 of 5 plus log to the base 10 of 4 is log to the base 10 of 5 times 4, which is 20. And again, you might have to be able to go back the way. So if you had log to the base 20, you could log to the base 10 of 20 is the same as log to the base 10 of 5 plus log to the base 10 of 4. Very similar, the second one is log to the base a of b minus, now this time, log to the base a of c, which is log to the base a of b over c. And again, if you had log of 8 minus log of 2, that's just log of 8 divided by 2, which is just 4. And the last one for us, log to base something of a to the power of n is equal to n log the base of that same thing times a. So this here we're assuming that the bases are the same in both of these ones. It's not mentioned, so we're assuming it's going to be 10. So here, for example, log of 8 is equal to log of 2 to the power 3. So just write your 8 in index form. Log of 2 to the power 3, which is the same as 3 times log of 2. You can test these all in your calculator. On your calculator, type in log of 8 and find out what that is as a decimal, and then do 3 times whatever it is for log of 2, and you will see that they're the same. Okay, three common results which are very, very useful. The first one is log to the base a of a is equal to 3. So for example, log to the base 10 of 10, log to the base a of a is equal to 1. For example, log to the base 10 of 10 is equal to 3. Now where this comes from, really this is just from your basic rules of logs. A to the power of 1 gives you a, and log of a number to a given base is a part of which the base must be raised to give that number. So you think here, you're thinking a to the power of what gives me a, and a to the power of 1 gives me a. So that's why log to the base a of a is just equal to 1. Same idea for this one. It says here log to the base a of 1 is equal to 0. And why that is just because a to the power of 0 gives you 1. So basically, log to any base of 1 is equal to 0. So here, log to the base 10 of 1 is equal to 0. Log to the base 4 of 1 is equal to 0. Log to the base 13 of 1 is equal to 0, and so on. And the last one, you have log to the base a of a to the power of n is equal to n. So for example here, you have log to the base 10 of 10 to the power 3 is just going to equal to 3. And if you can think why that is, 10 to the power 3 is going to be 1000. So you can see numerically why it is, as 10 to the power 3 gives you 1000. So basically, this 10 to the power 3 and this log, they just can't, log base 10, they just cancel each other out. And how I always remember that one is they're on the same button on the calculator. So if you look at where your log button is, shift and that log button is your 10 to the power of. So log to the base 10 and 10 to the power of whatever mean they are inverse functions, so they cancel each other out. So here, for example, if I was doing log to the base 17 of 17 to the power of 5, the log to the base 17 and the 17 to the power of just cancel out, leaving you the 5. Okay, we're going to look now at examples of how we can use these to simplify terms and change how these terms look. Okay, first example, we've got log of AC over B. You have to express it in terms of log A, log B, and log C. So once, I guess there's lots of different ways of doing this one, but I like to sort out the numerator and the denominator. So using my second rule of logs, I can write my expression like this. And I'm just going to leave my minus log B as it is. It's fine, it's sorted. But my log of AC is the same as log of A plus log of C. And that's you done. That's the first one done for us. Second one, a wee bit trickier maybe to see, but you would write your root a as a to the power of a half. Then using your third rule of logs, you could write that as a half times log of a. This one, again, this is something you need to be shown. Using my first rule of logs, I could write my 10c log of 10c as log of 10 plus log of c. Now log of 10, the base of this log, remember, is just 10. So up here we had this one. Log to base a of a is equal to 1. So we've got log to base 10 of 10 is also going to be equal to 1. So that's just going to be 1 plus log c. Again, a couple of ways of doing this one. What I'm going to do here is pull the power down. So the power comes down, and that's 2 upon log of ab over 10. Then that becomes 2 upon log of AB minus log of 10. So that becomes 2 upon log of AB, which is log of A, plus log of B minus log of 10. And then we'll just multiply in. That's going to be 2 log A plus log B minus log 10, remember, is just 1. So 2 times 1 is going to be 2, so minus 2. Okay, going to go on down here and look at a wee evaluating question and using the same rules that we had. So if we use the same rules that we have here, for the first one, the bases are the same, so that means we can use the rules, that's fine. So you can write that as log of 48 upon, 3 times 16, which is going to be log of 48 of 48. So the base is the same, so base is the same as the number, so that's really log to base a of a, which is just going to be equal to 1. Okay, this one looks a little bit trickier to me. If I look at this top line, not easy to see, but 7 to the power of 3 will give you 343. So really what you have on the top line is log to base 2 of 7 cubed all over log to base 2 of 7. So we'll write that as 3 times log to base 2 of 7. That's what our top line is, divided by log to base 2 of 7. And if you divide those, the log to base 2's of 7 just cancel, just leaving you 3. Okay, hopefully that was all clear. You're now ready to exercise 12B of your CCA textbook.